All right. I'm calling this a review lesson because we're going to take a break from what would usually be like the regular course, which would be like right now we should be starting quadratics. I was talking to a lot of the teachers and they agree. The way the book is set up, it's ridiculous. They assume that you guys should know some things, and we know for a fact that there's some things that you guys probably need a lot of review with. So we're going to do like a review unit. It's going to probably take about 2 weeks. We're going to review stuff on polynomials and square roots, okay? And then after that, we'll jump into the quadratic. So today we're talking about polynomials. We're going to be introducing you guys, or reviewing with you guys, what polynomials are, and then about adding and subtracting and multiplying, okay? So all that being said, let's go ahead and begin. If you didn't finish yet, guys, it's been up here a while. I'm just going to go ahead and say put review unit, lesson 1 at the top. You don't, the objective you can get later. All right, so here we go. So let's do some basic vocabulary first. When it comes to polynomials, there's a lot of vocab to be aware of. First of all, there's the monomial. Monomial. Mon means one, right? Nomial means number. So we're talking about one number, but in algebra, a monomial, here's an example. A monomial will have these parts to it, okay? It's going to have a number in the front called a coefficient. It's going to have a variable. And that variable will have an exponent. Now, it doesn't have to have all of those parts, but that's all the parts that could exist, okay? So, for instance, it might just be a 3. That's a monomial. Or it could be a 3x. That's a monomial.
Or it could be squared.
Or it could be x squared with no coefficient. Those are all monomials, but the 3 parts that could exist would be coefficient, variable, and exponent. Okay? So there's some basic vocabulary for you there. Yeah. Sure. All right. Number 2, constant. A constant is basically a monomial with no variable. So as an example, like 6. It's just a number, basically. So a constant is a monomial that has no variable. Constant means it doesn't change. Variable means it does. So if you don't have a variable, then it's not changing. Therefore, we would say it's constant. Okay? I'm going to go ahead and move on to another slide here, guys. Number 3, let's start off with an example here. If you have 2 monomials being added together, that makes it a binomial. Yeah, what's up, buddy? Yeah. David asked me to go back, guys, so I'm going to go back for a split second.
We're going to have to look on this, right?
Yeah. Yeah. I know. Sure. There's a seat open here in front of Hannah.
Huh?
Or behind Hannah. Yeah. I'm going to go and go. All right. So, binomial. when you have two monomials being added together. And lo and behold, what happens when you have three monomials being added together? A trinomial. You guys remember this now, right? Okay, so that's just some basic vocab for you guys. And, you know, and if you write notes with us, you won't fall behind. But if you eat chips and text, you will fall behind. Not if you're falling behind. Okay, so let's talk about adding and subtracting polynomials. Polynomial just means all of them put together. Monomials, trinomials, binomials, etc. So, we're going to do two things with these, maybe three if we have time. But two things for sure today with polynomials. We're going to talk about adding and subtracting them and also multiplying them. Okay? So, here's the deal. Rule number one. You can only add and subtract polynomials if they're like terms. I'll say monomials. You can only add and subtract monomials.
Does this go the same for binomials and trinomials?
Well, you know, I'm just going to say monomials because basically what a binomial and trinomial is that it's just a bunch of those put together, right? So yeah, the same rule will apply. So now you might wonder what makes two terms like terms. So what are like terms? They are two terms that have the same variable and exponent. So I'll pause there for a little bit. The next part. Okay. Okay, so let's say I have one polynomial, x squared minus 3x plus 5, and I want to add to it another polynomial, let's say 4x squared minus 6x plus 1. Go ahead and write that down.
Mine's already a picture of the brain.
Now, John. Never mind.
Say it.
But I won't.
Say it.
No.
It's already a regular one.
Okay. Now, the x squared is missing something. What is it missing? The coefficient, right? But if it's not there, that doesn't mean it doesn't have one. It's just 1, right? Okay, yeah. So now, here we go. Let's combine our like terms. This one has a variable of x and an exponent of 2. What else has an x to the second power? So we're going to combine those, and what do I get? So what? That's a good question. So what do you do? Add the coefficients. So 1 and 4 make 5, but you don't change the variable and exponent. So it's just that.
You're only adding the coefficient, but you're bringing down the exponent.
Yes. So let's write a note about that. Just add the coefficients. That's all you do. You don't change the exponents. And that's important because later today we're going to talk about multiplication. And that does change the exponents. But today, right now, we're adding and subtracting. Don't change the exponents, just add the coefficients. All right, this one has an x. This one has an x to the first power. What else has an x to the first power?
6. So it's negative 3 minus 6x, which is negative 9x.
That's right. So if I combine negative 3 with negative 6, I get negative 9, and the x stays the same.
And then plus.
And that's right. These are both, what do we call monomials with no variables? Constants. They're both constants, and those are like terms because they have the same variable, none. So we can combine those. So 5 and 1 makes 6.
That's all?
Yeah, that's it. That's all.
It'll be complicated. Simple steps, you know.
And then on your homework, I'm going to give you guys really hard problems that I don't teach.
Stop.
I'm just
I've done
joking.
that before.
That's the point when I'll be like,
I know, students always feel that way. It's not
yeah,
uncommon.
that's the point when you'll be like, yeah.
Can I proceed?
No.
Yes, sir.
John's opinion doesn't matter.
I agree.
Really? My opinion doesn't matter.
Just a little bit.
Is this example 1 still?
Mr. Bailey, I'm gonna remember that next time you do my opinion something.
Is this still example 1?
This is going to be a student practice. I want you guys to see if you can combine your like terms. Go for it. At this point, I wouldn't because you've got the right answer and all I'm going to do is go over it. So you just have to as long as you're participating. Now, when I get on to the next example, I would expect you to be with us, right? So just use it responsibly. It's like alcohol. All right, here we go. I don't think Paris is with us today, so I'm going to go to Michael. Michael,
Yes.
what'd you get?
3x to the power of 2
Yeah,
minus 3x
yeah.
plus 13.
Beautiful. All right, so negative 4x squared goes with the 7x squared, and 7 take away 4 is 3, right? And then this guy has nobody to combine with. It's a loner. Negative 3x. Just bring it down the way it is. And then 5 and 8 are my two constants. They're like terms, and they make 13. All right, so let's move on. Let's take a look at another example. This one's going to be a subtraction example, which is a little bit different. So example 2. Let's say I had 8x cubed minus 4x plus 1, and I wanted to do minus 2x cubed plus 5. Subtraction is different. Of course, this is an example. Examples are the ones that I do. Student practices are the ones you do. Guided practices are the ones we look at. All right. So when you are subtracting this binomial over here, when you're subtracting that, you're really subtracting each term. So a good way to start is, maybe write this note, when subtracting, what we're going to do is we're going to distribute a negative 1. Okay? So this, think of this as a negative 1. And we're going to multiply that into this second set of parentheses. That's because we're subtracting it. So now I'm going to have 8x cubed minus 4x plus 1. That one's staying the same. But this second set, both of these change their signs.
Wait, I'm so sorry, Mr. Bailey. I wasn't paying attention.
So when you're subtracting, distribute a negative 1.
So you're gonna leave the first one?
Yes.
Oh,
Yeah.
so basically just multiply the other parentheses and then just solve from there.
And then from there, you just follow the same steps as the last one. So 8x cubed combines with negative 2x cubed to make.
Can you please wait?
I can wait.
6x. And then minus
So the negative 1 is gonna change everything.
It just changes their signs, basically.
Question. What was there before you put the negative 1?
Just a minus.
So if it's a minus, you have a negative 1.
And then we distribute it.
So positive 1 minus 5 is negative 4, correct?
Hmm?
Positive 1 minus 5 is negative 4, correct?
Positive 1. Yeah, you're right.
So would the equation be 6x cubed minus 4x minus 4?
Let's see. The negative 4x has nothing to combine with, right? So we're just going to bring that down as is. And then we have the 1 and the negative 5 makes,
That's gonna make a negative 1.
there we go. Okay, so the only difference when you're subtracting is to distribute a negative 1 into that second set of parentheses first. After that, it's the same. Okay? So, let me throw another one at you. Yeah. Show me what you got. Here we go. So I'm going to ask Kiara, what'd you get for your answer?
My first.
The answer?
Yeah,
Negative 3x plus 4.
she's right. So let's see why. You should have started by distributing this negative like it's a negative 1, which is going to make this become a negative 8x and a positive 1. Then when you combine the 5x with the negative 8x, you get negative 3x. And then when you combine the 3 with the 1, you get 4. So that's adding and subtracting polynomials. Yeah, what's up, Chris?
Like how come it's plus 4 when you're subtracting?
So what's happening is we're subtracting, right? So what you're doing is you are subtracting a negative 1. And when you're subtracting a negative 1, that's like you're adding 1. Good question. All right. So I didn't want to do that. I'm a little confused. Oh, okay. All right, guys. So we're going to be changing gears here a little bit. Ready? B, C. Multiplying
No.
monomials. Multiplying monomials. So, two things you have to do. You're going to multiply the coefficients, and you're going to add the exponents. Multiply the coefficients and add the exponents. That's how we're going to do it. So I'll show you what I mean, but it's nice to have the notes now. But we're going to, that's how you multiply. So it's different than adding. So when adding, all you do is you find the like terms, add the coefficients, right? But when multiplying, do they have to be like terms? I didn't say that. They don't need to be like terms. But what you do want to do is you want to multiply the coefficients and add the exponents. So let me give you an example.
So this will kind of throws the rules of adding and subtracting out the window.
It's totally different. It's totally different, yeah. Yeah, because it's not the same thing. That would be kind of like somebody who raised a cat their whole life and then somebody breeds a dog and they're like, oh, so we're just going to throw all the cat rules away. It's a whole different creature, right? Same thing. Multiplying is all different than adding and subtracting.
My
So.
mom tried training our cats with the dog.
Oh yeah, I've seen people train their cat to go to the bathroom on the toilet. Does anybody's cat do that?
Do what?
You can train your cat to go on the toilet.
Does yours do that?
No, I don't have that kind of time to train my cat.
My foot's asleep and it feels like I'm stepping on needles.
I just open the door and say, all right,
Wait, you mean
here we go.
you don't give your cat Kayla a box?
I love my kitties. No, they go outside, but I do love my kitties.
And that's why they run away.
Sometimes. Okay, let me ask you guys a question. We're going to multiply these. You guys recognize the little dot there, right?
Yeah.
Okay.
That's really tiny.
All right. Now, are those like terms?
Hang on.
No, sir.
Do they have the same variable?
Yeah.
Do they have the same exponent?
No.
They don't have the same exponent. Therefore, they're not like terms. But can I still multiply them?
Yes.
Yes, because when you're multiplying, you don't need like terms. So, what are my coefficients here? 3 and 5. What do you do to the coefficients?
You add this.
You multiply them. So what's 3 times 5? 15. Bring down your x. What do you do with the exponents?
You add them. It's 15x by 2 power 5.
That's how you multiply monomials.
That's wicked.
It is wicked.
Henry, keep talking.
So you add?
Is wicked a good thing?
No.
Oh, good. Like, wicked! That kind of wicked? Okay. so there's like, wicked. And then there's different kinds of wicked. All right, I want to do another example just to make sure you guys have got it. 2x squared times 10x. No,
Example 4?
you'll appreciate this extra example. I guess we'll call it B, huh? Let's call the last one A.
Good idea.
We'll call that A,
Example 3A.
and we'll call this one B. All right, now this one's tricky, so watch out.
Hit me.
Are you guys ready?
That dot's still
Yeah.
really small.
So what is my coefficients are negative 2 and 10. So if I multiply those, what do I get? Negative 20x. Now, the exponents, this is tricky. This one's 2. What's that one? It's 1. It's not 0. So there's actually a 1 there. It's a secret 1. So what's my exponent going to be?
3.
3. Because 2 plus 1 is 3. So if they don't have an exponent there, don't assume it's 0. It's actually 1. Okay? So let me throw a couple at you guys. Student
No,
practices.
No, that's called student hours. What?
What?
That did not work.
He tried. He tried.
Student
It
practice
was
Not
what?
really.
good effort.
Thanks for asking.
Can I change it to A?
Sure.
Just to freak you guys out a little bit?
What do you mean A?
You're not.
Hannah's already freaking out. What's A?
No, President know what he meant, but I see that now. No, that's fine.
Kind of.
Wait,
Mr. Bailey, can it be a
why are you doing it so much?
Because I believe in you.
Can there be a
So
negative
he makes sure
exponent?
he draws it right.
Yes, there actually can be negative exponents. We're not going to talk about those right now.
Excuse me.
Okay,
No, that's mean.
go ahead.
When you're helping us.
Oh, it's just multiplying and then.
Henry, next time you want to sound confident with yourself, please make sure you actually are.
Okay, here we go. This guy on the outside, we're going to multiply it by all 3. You guys know how to distribute, right?
No.
It's just that now I'm distributing a monomial and not just a number, right? It's not just a constant. I'm actually distributing a monomial. So 5x squared times 1x squared, what will that be?
6.
X to the power of 4.
Good. How about the next one? What's 5x squared times negative 3x?
Negative
15.
Cube.
Yeah.
Cubed, right? Because 2 plus 1 is 3.
Oh, there's a 1 there.
Oh,
Yeah.
yes.
All right.
And then the last one is,
10x squared.
yeah, so it's
Oh, wait.
2 times 5 is 10, right?
Yeah.
Oh,
And then it's
there.
x squared doesn't change because
No, because
there's no other x's, right?
Oh, that's low.
Okay. So student practice time?
No.
No.
What am I on, student? Yes, Les. Yes.
Student practice 4.
Okay. It's like there's one student practice for every example or something. It's
Oh my
just
God.
crazy.
Yes. No, there were just like 3 for the other one.
That's
There's
crazy.
3 columns in one student practice.
That's crazy.
Okay.
Wow.
Make me proud. So, let me ask Nelson. Nelson, what did you get?
That's,
Okay. Now,
I got that.
let's go ahead and do one more thing before we call it a day. You guys ready?
I didn't want to do these. Not really hard, but I actually know what I'm doing.
You didn't see it?
We're doing more? Oh, is it?
One more.
Wait, you skipped division.
Huh?
My bad. Did
Okay.
you hear me?
Okay, guys. Let's see what that's all about. You we're not.
Wait, is this another practice?
Okay, guys, now I'm going to give you a bit of a brain teaser here. So,
I just realized right now. Alright, we're not related, guys. No way.
Yeah, I'm not doing this.
Hannah came to my class at lunch, and we did these because she likes to party with math.
I
And
didn't come to your house at all.
she did a problem,
I was here.
and this was her answer. My question to you is, what was the original problem? So, go ahead and see if you can figure it out. Go ahead and see if you figure it out. Uh-huh. Where'd you go?
Christmas meal.
3x?
My Christmas meal, I need
Plus 6.
Plus 4.
Oh,
Wait.
Wait,
yeah,
no,
plus 6.
4.
Oh.
Whoopsies. I said it
Chris,
different.
you messed me up.
So that's the
This is a good answer. This is a good answer. It's not the best answer, but it's a good answer.
minus 3x.
John's not with us. Let's try. Yes, what's yours?
Minus 3x. 2x. Plus 4.
Good. That's a good answer.
So
What's our best answer there, Nathan?
6x, x plus 2.
Okay.
Really?
Does anybody know why this is the best answer, Vanessa?
Can you take out the biggest component?
That's what it is. If you, whoever takes out the most out of the parentheses got the best answer.
Yeah.
Is it bad that I want to go back and fight you?
Don't you guys agree that Nathaniel took out a bigger number than everybody else?
Yeah.
And it also applies to exponents. In this case, you can only take out one x, but the more x's you take out, the better. Okay? So I'm going to show you guys how to do that, and then that will close out our day. So here we go. I think we're on letter E now. We call this taking out a greatest common factor.
I'm running out of paper.
Oh, yeah.
We're getting there.
Go to the bathroom.
I'm already on the back.
Then go to the next page and just name it like part continue.
This is our last thing, so hang in there.
no.
12x to the third plus 6x squared. Let's say I have that. I want to take out the greatest common factor. So this is backwards from distribution. I want to work backwards from distribution. So basically,
So what we just did?
yeah, we're going to put some parentheses there. We want to take something out. And what I take out, I want it to be the greatest common factor. I want the best answer.
Okay.
6.
So so let's slow down. Let's give people a chance to catch up. So this is the first step. Step 1 is to set it up, okay? The next thing you want to do is you want to ask yourself, what's the biggest coefficient
Oh, I got it.
you can divide out? So look at my numbers here, 12 and 6. What's the biggest number you could divide into both of those? 6 is. 6 is. So I'm going to put the 6 out here.
Wait, I think I did it.
Now if I divide 12 by 6, what do I have left?
2.
And if I divide 6 by 6, what do I have left? 1. So the 12 is going to become a 2 and the 6 is going to become a 1. But we also have to take out some x's here. Now, how many x's can you take out?
1, 2. Because the biggest one is 3. So
The smallest one is squared.
That's right. You can only take out what they can both give. How many x's can this guy give?
3.
How many can this give?
2.
But you can only take out what they have in common. They both have at least 2. So you're only allowed to take out 2. So I'm going to put x squared out here. Now, if you take 2 x's away from here, how many will be left? And if you take 2 x's away from here, how many will be left?
9.
So your final answer, if you want to write it prettier, would just be this. So You divide the numbers by the biggest common factor number you can find, and you take out as many x's as they both can give. We'll do another one. Yeah. I took out 2 x's because that's the most x's I could take out. So it won't always be 2 x's. No, it could be more. It could be less.
It could be nice.
That's right. Let's do another one.
No, dude.
Well, that's just the last topic, but you guys need a few examples to get the idea here, I think. So, negative 8x to the 4th minus 2x. Okay, so step 1 is what? Set it up. Bam, bam, bam. Okay. Now I want you guys to go ahead and find for me what's the biggest number you can divide. I'm going to call on you with my card. Don't shout it out. What's the biggest number we can divide out? Don't write anything. Just do some mental math. Think for a minute. What's the biggest number we can divide out of both coefficients? So Eric, what would that be? We can go bigger. But one is true, but we can go bigger. Let's try Augustine. What's the biggest number we can divide out of 8 and 2? 2, right? So we could take a 2 out. Now, just for fun, anytime the number in the front's negative, let's just make it a negative. So we're going to divide out a negative 2. So I'm going to divide both of these by a negative 2. What would go here, you guys?
Negative 4 positive.
And what's negative 2 divided by negative 2 going to be? Okay, now I want you guys to see how many x's you can take out. Don't shout it out, but how many x's can I take out?
You forgot to put the subtraction in the middle.
Well, actually, negative 2 divided by negative 2 is positive 2.
Oh.
I'm sorry, positive. So it's actually going to be a plus now. So thank you for asking about that. All right, so that became a plus is what Henry was talking about because 2 negatives make a positive. Now, how many x's can we take out? I'm going to come at David here. How many x's can we take out, David? Only 1, because this guy only has 1 to give. Oh, I see what you're saying. You were talking about the x's. Gotcha. So, Gabriella, if I take 1 x out, how many x's are left here? How about here? That's right, there's no x's left, because it only had 1 to give. All right, so I'm going to let you guys do one completely on your own now. You guys ready?
No.
Wait, Mr. Before you
This
do
part I
that,
don't-
really quick, I think I found a blue way, because you know how you keep asking us what's the big number you can take out of it?
Yeah.
You can just use the number at the end.
That's not always true.
That's not.
You can use it
That's
just
not
as the
always true.
smallest number.
For x's, yes, but he's talking about coefficients. All right, so here's one for you guys. Ready? Let's
I
do
don't like this. I don't understand.
24x to the 3rd minus 14x to the 5th.
Mr. Bailey, do you have any tissues?
Yes, on my table up here, there's some tissue.
Where?
Those are
Okay.
That one. No, because 7 doesn't go into 24.
7, 14, 20. Oh, yeah.
Okay. All right, I'm going to put the answer up here if you're interested.
Here goes Mr. Bailey. Can I come to you?